Good morning, grade 10. I'm here summarizing for you the the 4 lessons in the exam as I promised you before. So as I told you before that 7.1 chemical formulas is the basic one that you have to master it to be able to solve all the other lessons. So it's basically chemical formulas and name. You need to be able at the end of this lesson to write a chemical formula of a compound or name it if you have the chemical formula in front of you. So by the end we will be able to write and name the following chemical formula of ionic compounds and of covalent compounds. For the ionic compounds, if it is monoatomic ions, I'll have monoatomic ions or polyatomic ions. What is monoatomic ions and what is polyatomic ions? Monoatomic ion, from its name, monoatomic, means that the ion monoatomic ion, that the ion made of or composed of one atom. Okay, like what? When I say sodium chloride. Sodium chloride. Sodium is one element, sodium. Chloride is one element, chloride. So each ion, this is ion and this is ion. Each one of them is monoatomic of one element, Na plus and Cl negative. Why it is plus, why it is negative, losing and gaining electrons, if you understood and remembered this from the first time, so it is essential to know it. If it's no, so I don't want to go to that details now. Okay? Naming that the positive are called cations and the negative are anions. So here the only thing I want you to focus on that monoatomic ions, يعني they are made of one element.
Hello, how are you?
While polyatomic ions,
Alhamdulillah, Good. So
like
far,
what?
But يعني I don't.
Okay, so back. Polyatomic ions means that the ion is made up of more than one atom. Like when I say nitrate, it is an ion have a charge and made of more than one element, like here nitrogen and oxygen, so it is polyatomic ion. All what I want you to memorize from that the ionic compounds can be monoatomic, made of monoatomic ions like NaCl, or polyatomic ions like NaNO3 nitrate. See here, monoatomic Cl1 element, and NO3 is made of two elements, nitrogen and oxygen. In case you have polyatomic ions, as you know, we do in class, we do a circle around it, and we don't, or we deal with it as a one bulk, that we don't break it down. So we move it from the reactants to product as it is. It's like one bulk, one bunch. It's not broken down. طيب. Before we go to the lesson, there's some basics. I want you to memorize it from the periodic table. Here. Once you have the periodic table in the exam, you will figure out that there is a ladder here. This ladder is the what? Excellent, metalloids. Before the metalloids, all that side are what? Metals or non-metals? Excellent, metals. And after the zigzag line here, or after the metalloids, non-metals. Non-metals. Okay? Type. As we talked before in the first term, that the compounds are mainly ionic compounds or covalent compounds. Ionic compounds or covalent compounds. If they are ionic compounds, so it is between metal from that side and non-metal. From that side. Why it is important to know? Because it will differ in naming. Each one of them have different system. While covalent compound, both of them are in from the nonmetals, from that side, from that part only. So the covalent compound is a nonmetal with a nonmetal. The covalent compounds are following system called the prefix system in naming them, while the ionic compound following system called stock system. Okay? طيب. Now we will practice some questions so it's clear for you. But before that, here the most important part in the periodic table that you have to write once you get your periodic table, that the group 1 oxidation number is +1, group 2 +2, skip the transition elements, group 3 +3, skip here, then -3, -2, -1. Skip group 14 here, it doesn't have any oxidation numbers. What you are writing, miss? What is +1, +2, +3, -3, -2, -1? This is the oxidation number. What means oxidation number? It is the number of valence electrons lost or gained. So the electrons, so the atom is following the octet rule or reach the stability of octet where the outer shell is fully filled. So here all the elements in group 1 lose 1 electron, so its outer shell is full. All elements in group 2 lose 2 electrons. Here lose 3 electrons. Here gain 3 electrons. Here gain 2. Here gain 1. And group 18 0. They don't lose or gain. Okay? This you will use it to name or write the chemical formula properly. Let's put it aside. Once we'll use it, we'll get it back. Let's start by the first type, which is naming of ionic compounds. Naming of ionic compounds. Okay. Sodium nitride. Sodium nitride. Okay. Where is sodium? Here. Is it metal or non-metal? Where it exists? Before the metalloids. So it is metal. And nitride, nitrogen. Where is nitrogen? Here is nitrogen. Metal or non-metal? Non-metal. So metal with non-metal, it is what? Ionic compound. So it follows the stock system. What stock system say? Naming of the stock system, simple like that. The stock system nomenclature, that the cation, you give it the same name. Same name. While the anion, you add to it the suffix ide, ide. What is cation? The positive ion. What is the positive ion? The metal that's written first. Anion, negative ion, that it's written second, the non-metal. You add I to it. So here in the example we have sodium nitride. Sodium nitride. We figure out from the periodic table where's sodium in group 1, and it have the symbol of Na, capital N, small a, and it is in group 1, so its oxidation number is +1. While the nitride, nitrogen, N, in group 18 here, 1, 2, 3, 4, 5, 6 at here, group 6, and its oxidation number is -3. What you will do next? Crisscross. So the sodium will take the oxidation number of nitrogen without a charge, 3, and the nitrogen will have 1. We don't write 1, so it will be like that. Sodium nitride. So let's try the second one. Aluminum chloride. Aluminum chloride. Where's aluminum? Here. What the oxidation number of it? +3. So I will write Al +3. Chloride here. What its oxidation number, as you can see? Excellent. -1. Crisscross. So it is Al1. We don't write the 1. Cl 3. Excellent, without a charge. And don't forget that we don't write the charges, and the second letter of any element have to be small, capital and then small. Aluminum chloride. Okay, in some cases they will not mentioning or giving you elements that they are in the main groups, which group 1, 2, 1A, 2A, 3A, 4A, and so on. They may give you from the B group or the transition elements. In this case, the question will mention for you that the oxidation number in a Roman number, in a Roman or a Latin number. Like here, when he say iron 3 oxide, this mean what? That iron, the symbol of iron is Fe, and oxidation number is 3. He is telling you that. He is giving you the oxidation number, but simply it is in Latin. You will change it to number here. Okay? Oxide. What is oxide? Oxygen. Where is oxygen? Here. To have the oxidation number -2. Crisscross without charges, so Fe2O3. Iron oxide. Now the next one, pause the video and try to solve it by your own. Platinum, Pt, platinum from the periodic table here. Platinum 2, so +2. Chloride, Cl, oxidation number is -1. Okay, so by writing it, it will be crisscross as we said, so it will be platinum 1 for the chloride, and the chloride will have the 2 of the platinum chloride. Okay, this is a kind of question that he will give you the name and you write the chemical formula. It can be the opposite, that I will give you the chemical formula and you name it. I will give you the chemical formula and you name it. In this case, it's super easy that you will follow the stock system, which is here. Let's say I will take the aluminum chloride here. What I will do, the first one, which is the cation, I give it the same name. I will go to the periodic table. Where is the periodic table? Here. Where is aluminum? Al. It is written aluminum. I will write it as it is. The second one, chlorides. Here, Cl. It is in the periodic table chlorine. In the periodic table, it is chlorine. I will not add it, I'll write it chlorine, I will add it chloride. As the anion that have the negative, the non-metal, you switch or replace the ion with ide. So it will be aluminum chloride. Let's do another one. Let's say here Fe2O3. Iron, Fe in the periodic table. It's written what? Iron. And here O is what? O is oxygen. Oxygen. Iron as it is. Oxygen. We don't write it oxygen. We write oxide. We add also ide. Okay? And because here I know that the oxidation number of iron, it's written here, so it is iron 3. Okay, Now we finish the ionic compound where it is monoatomic. Polyatomic, it is easy because it's based or depend on only memorizing those names and their oxidation number. No way, rather than I give you before that mnemonic strategy that you remember this slogan or statement and you can match it. You wanted to do it, go back to the lesson. Otherwise, simply memorize it as it is. As it is. Hydroxide OH, nitrate NO3, nitrite NO2. And here I want you to figure out ate and ite, nitrate, nitrite, O3 and O2. Where ate have more oxygen than ite, NO3 and O2. So hydroxide, nitrate, nitrite, chlorate, carbonate, sulfate, sulfite, phosphate, and ammonium. What you will do simply, you care about the chemical formula and the oxidation numbers. And as I told you, each one of them is react as a bulk, no way to be broken otherwise in a very harsh chemical reaction. It's not the normal chemical reaction that we are taking now. So you don't break it down in any of your balancing or chemical reaction. So let's say here sodium chlorate. Sodium, as long as I found it's 8 and not ide. It's not ide. It is 8. So it is polyatomic or monoatomic? 8. Excellent. Polyatomic. If it is ite, also it is polyatomic. But if it is end by ide, like we have here, chloride, oxide, it will be what? Chloride, oxide, monoatomic. Monoatomic. Okay? So here, sodium chlorate. Sodium from the periodic table. Where's sodium? Sodium. Na. Chlorate. Where's chlorate? Here. So it will be chlorate. طب double check the oxidation numbers. Sodium is +1. Chlorate as written here. Chlorate is -1. So +1 and -1. When you replace them, so it's Na1, ClO3, 1. Do we write once? We don't write once. So it is sodium chlorate. But let's see the other case. We have calcium phosphate. Calcium, where's calcium? Here. Where's calcium? Here. Ca, and it exists in which group? Second group, so +2. So calcium, Ca +2. Phosphate, where is phosphate? Here. Phosphate. So PO4 3 minus. What you will do next? Crisscross. So calcium phosphate 2. But can I write like two numbers like that? No, so I'll put a bracket here. Okay, the calcium take the 3 of the phosphate without a charge. The phosphate take the 2 of the calcium without a charge. As long as it's polyatomic, I will write it in a bracket. So I'm saying, and it's clear for me, that the 2 is for the oxygen and for the phosphate. For the phosphorus, sorry. For the oxygen and for the phosphorus. By putting it in brackets. Okay. And last one is the covalent compounds. Covalent compounds are following different system called prefix system. What prefix system? Based on the number of atoms in front of you, you will say if it is mono, di, tri, penta, tetra, like in geometry. When you say pentagon, it means that it have 5 sides. When you say hexagon, have 6 sides. Exactly here. When I say I have carbon tetrachloride, tetra stand for 4. So this means that I have carbon, nothing here, so it's 1. Carbon, 1. And chloride, how many of it? 4. طب how I know it is covalent and it's not ionic? First, that you mention the prefix tetra, following the prefix system. Secondly, if you can't see the carbon, where's the carbon? Here, non-metal. Where's the chloride? Here. Also, it's a non-metal. So you are following the prefix system, which is adding mono, di, tri, and so on. طب here, di-arsenic pentaoxide. Di-arsenic pentaoxide. Okay, where's arsenic? If you're gonna to look for the name arsenic, you will find that arsenic is AS here. Arsenic. And oxide, oxygen. How many of the arsenic? Di means what? 2 of it. And penta means 5, so 5 of it. So it is AS2O5. Di-arsenic pentaoxide. Exactly like the others, I will give you the name and you write the chemical formula, or the opposite. So if we took another example here, like let's say carbon sulfide. Let's say carbon sulfide, okay. Okay, let's take this. Tetra phosphorus dicoxide. Tetra phosphorus dicoxide. How many phosphorus do I have? Excellent, 4. How many oxide do I have? Oxide means oxygen. How many of it? Dec stand for 10. Dec stand for 10. So 10. And phosphorus 4. Tetra phosphorus dicoxide. Okay, this is the first lesson. I will send you the review questions of the textbook with this answer key. Solve it all to be confident till I upload the next videos.